Hi, this is Mrs. Myers, and this is lesson 1.4. We're going to be talking about conditional statements, which really is just an if-then statement. When you write a statement with if, like if an angle measures 24 degrees, here's an example, then it is acute. Since it has the if and the then, it's called a conditional statement. The hypothesis is the part between the if and the then. So in other words, it comes right after the if. And the conclusion is the part following the word then. So if we were going to label this example here, an angle measures 24 degrees is the hypothesis, and it is acute is the conclusion. I want to stress here, when you get this kind of a question on a test or a quiz, if it says state the hypothesis, you want to make sure you're just saying an angle measures 24 degrees. Do not include the word if. The if word is not part of the hypothesis. The hypothesis is an angle measures 24 degrees. The conclusion is it is acute. The if and the then you don't want to include in the hypothesis and conclusion. So this is called a Venn diagram. When you have a Venn diagram, you can put the if-then into the Venn diagram. So in this example, if an angle measures 24 degrees, then it is acute. The acute angle part is the bigger category. There's lots of different angles that can be called acute. And inside the littler circle here would be the 24-degree angle, because that's a subcategory of the big acute angle classification. So the big part is always going to be your conclusion, right? And the part that's smaller, and 24 degrees in this case, that's where your hypothesis goes. So if you think about hypothesis is the part that follows the if, and the conclusion is the part that follows the then. So I always think of the word if starts with the word I, and I goes inside. It's the one that's inside the bigger circle is the if part, the hypothesis. Okay, so if we write our own conditional, let's say if you do your homework, then you will do well on the quiz. Okay? So the hypothesis of this statement is the part that follows the if. Remember, we're not going to include the word if. So hypothesis is that you do your homework. And the conclusion is that you will do well on the quiz. That's the conclusion. Remember, don't include the if or the then words. So in our Venn diagram here, if we put the doing your homework would be on the inside here, and doing well on the quiz is the bigger category. In other words, there might be other reasons why you do well on the quiz. Yes, you do your homework, so you do well on your quiz, but you also might study really hard, and so you do well on your quiz. That's another subcategory. You might retake formatives, and so that's why you do well on your quiz. You might come for extra help. So that's why you do well on your quiz. But so the lesser category, the smaller category is doing your homework. If you do your homework, then you will do well on your quiz. Okay, so let's move on here. Given the conditionals below, identify their hypothesis and conclusion, then complete the Venn diagrams. So we'll do the first one together, and then I'll let you do the second one on your own. If Joe lives in New York City, then he lives in New York State. So hypothesis comes after the if. So Joe lives in New York City. Conclusion comes after the then. He lives in New York State. He lives in New York State. So our Venn diagram, the more broad category is living in New York State, and the more specific category is living in New York City. Right? Because you could live in Albany, and that's in New York State. Right? So there's going to be other categories that go in the New York State category. Okay, you guys try part B. Pause the video and come back. Okay, so this is what you should have. Angles are adjacent is the hypothesis. They share a vertex is the conclusion. Your Venn diagram looks like this because there's other types of angles that can share a vertex, like vertical angles share a vertex, right? Okay, let's move on. So given the following statements, write a conditional. Oops. Dolphins are mammals. So this is a general statement. We want to write it as an if-then. If this is kind of implying that all dolphins are mammals. So the bigger category is mammals, and the smaller category is dolphins. So we're going to say if it is a dolphin, then it is a mammal. All right, vertical angles share a vertex. Vertical angles share a vertex. If angles are vertical angles, then they share a vertex. So when it says write as a conditional, that just means turn it into an if-then statement. Okay, truth value is just saying, is this conditional true or false? A counterexample is an example. Sometimes it can just be a diagram to show that something is false. So find the truth value of each conditional, and then if it's false, give a counterexample. This is an important word to understand, counterexample. I could say, you know, all movie stars are female. Well, that's false. What's a counterexample? Well, as a counterexample, I could name any male movie star, and that would be my counterexample. So it's just coming up with an example of something that you can say is false. Okay, if you are playing a sport, then you are playing lacrosse. True or false? Well, that's going to be false. Why? Because you could be playing a different sport, right? If you are playing a sport, then you are playing lacrosse. Well, if you're playing a sport, you might be playing, let's say, tennis. That's a counterexample. If a pair of angles form a linear pair, then they are supplementary. If a pair of angles form a linear pair, then they are supplementary. That's true. That's actually a postulate that we learned. All linear pairs are supplementary. So we're not going to be able to come up with a counterexample for that one because it's true. All right, to find a converse, of a conditional, we're just going to switch the if with the then. In other words, we're switching the hypothesis with the conclusion. So, for example, first we're going to take this, a giraffe is an animal with a long neck, and we're going to turn it into an if-then. If it is a giraffe, then it is an animal with a long neck. Just a little tip here when you're writing conditionals. Look for the word is or was or some verb, any verb. The part before it is what you're going to turn into your hypothesis, and the part after it is what you're going to turn into your conclusion. So you don't want to say, if a giraffe is an animal, then it has a long neck. That's not going to be correct. You're going to say, find that verb and split it. If it is a giraffe, then it is an animal with a long neck. Okay? This actually is true. Right? Giraffes have long necks. But let's write the counterexample. I'm sorry, the converse. So we're going to identify what the hypothesis is. There's no counterexample because it's true. The hypothesis is it is a giraffe. The conclusion is it is an animal with a long neck. The converse, then, we're just going to switch the place of those two things. So we're going to start with the word if. So a converse still has the word if, and it still has the word then. But we're going to switch the hypothesis and the conclusion. So the conclusion is now going to become the hypothesis. So if it is an animal with a long neck, then now the hypothesis is going to become the conclusion. It is a giraffe. So you're just switching it around. Our original was, if it is a giraffe, then it's an animal with a long neck. And the converse is, if it's an animal with a long neck, then it's a giraffe. Now, is the converse true or false? That's actually going to be false. Because there are other things that have a long neck, other animals, right? So maybe we'll say goose. A goose is an animal with a long neck, so that can be my counterexample. All right, so a little geometry here. All squares are quadrilaterals. Write it as a conditional, and then the counterexample if false. I'm going to have you try these on your own. Pause the video and come back. Okay, so the conditional would be if it is a square, then it is quadrilateral. Remember, find the verb, in this case are, and you put the hypothesis with what's before it and the conclusion with what's after it. Okay, it is true. All squares are quadrilaterals. When we write the converse, we're saying if it is a quadrilateral, then it is a square, which is implying that all quadrilaterals are squares, and that's not true. That's false. So an example of a quadrilateral that's not a square would be a trapezoid, maybe a rhombus, right? Counterexample is anything that is a quadrilateral but's not a square. Okay, write the conditional that you can conclude from the Venn diagram. So the smaller category is the cows. Remember, that's inside. That's the if part. I for if, I for inside. So if it is a cow, then it is a farm animal. Okay, So the last thing here on this page is talking about this word, biconditionals. Okay? And that's what goes in this first blank here. Biconditional. And it's a single true statement that combines a conditional and its converse. And you can tell a biconditional because it has the phrase if and only if in it. The abbreviation for if and only if is IFF. Now, this can only be written if the conditional is true and the converse is true. We just saw that not all converses are going to be true. So this is a special case when you can actually reverse the logic and it's true both ways. So let's look at this one. If the sum of the measures of two angles is 180 degrees, then the two angles are supplementary. Here's our conditional. There's our hypothesis, and this is our conclusion. If we write the converse, we just have to switch those. So we're going to say if two angles are supplementary, then, and then the hypothesis is going to become our conclusion now, then their sum is 180. I abbreviated a little bit there. Now, is the converse true? Well, let's think about it. If two angles are supplementary, then their sum is 180. Is that true? Yeah, it is true. So we can write a biconditional. Now, notice we're not using the word if, we're not using the word then. We're taking these statements, hypothesis and conclusion, and we are connecting them with the phrase if and only if. So you can take this statement and start with that. The sum of two angles is 180. Okay? Don't start with if, start with the hypothesis. The sum of two angles is 180. Then we're going to insert the phrase if and only if. And then we're going to end with what our conclusion was. The two angles are supplementary. So a biconditional does not start with if, it starts with the hypothesis. The sum of two angles is 180 if and only if the two angles are supplementary. So if you look at number 7 here, state the two conditional statements that form the biconditional below. Now they're giving you the if and only if statement, the biconditional. So if we identify the hypothesis is this, an angle measures 90, and the conclusion is this, it is a right angle. So if they're asking us to write the two conditionals, we need the if-then statement that is the original, and then the if-then statement that is the converse. So if an angle measures 90 degrees, so we're just using hypothesis, then we'll use this, it is a right angle. So the converse is just going to switch that hypothesis and conclusion. Right here we're going to say if it is a right angle, then it is an angle that measures 90 degrees. Okay? All right, so that brings us to a good definition. key word here? Reversible. A good definition is reversible. It can be written as a true biconditional. In other words, that is a really special case that we just did, where you can take the conditional, oops, you can write the converse, and they're both true. If they're both true, you really have what we a good definition, right? If it's reversible, it can be considered a good definition. So given the definitions below, write both the conditional and the converse, then write the biconditional. So if you write the conditional and the converse and they're both true, then you can write the biconditional. If that's the case, then a quadrilateral is a polygon with exactly 4 sides, can be considered a good definition. And then same thing here. Two angles that have equal measures are congruent. That can be considered a good definition. If you can write a conditional and a converse that are both true, which therefore means you can write a biconditional. So here's the definition of congruence, which we've talked about before. If the measure of angle A equals the measure of angle B, then A is congruent to B, and if A is congruent to B, then the measure of angle A equals the measure of angle B. That's a conditional, and it's converse, and they're both true. So you could write it as a biconditional, and that turns out that this is a good definition. Okay, I'm actually going to, this video is getting a little too long, so I'm going to pause it, put all the answers in, and then you can check your answers. Okay, so if you did these conditionals and converses, remember if they're both true, then you can write the biconditional, and that was the case for both of these. And then down here, is this a good definition? A square is a figure with 4 right angles? No, it's not a good definition because it's not reversible. If we make these if-then statement, if it is a square, then it's a figure with 4 right angles. That's true, but if we reverse it, if it is a figure with 4 right angles, then it is a square, that's false. You can have a figure with 4 right angles that is not a square, like a rectangle. Okay, so that makes it false if it's not reversible. Makes it not a good definition if it's not reversible. Okay, and then an obtuse angle, we want to say it's greater than 90 degrees, not that it's greater than an acute angle. All right, thank you.